We got to record. The first thing we're going to talk about is domain. And that is always the input number. Do you remember in terms of variables, which one is usually our input number? Like which one are we plugging in to find the other? Is it X or Y? X, right? This is our X. So the input is our X values. We'll just do it like this. So these are your X values, typically speaking, okay? It's the input. It's what we are plugging in to find what comes out of it, okay? So that's domain. And then there's range. And the range is the output values. Meaning when I plug in an X, what I get out of it is my Y, okay? So this is typically your Y values. Josiah, what are you working on there?
Yeah.
Notes? Okay. So the range is the Y values. The domain is the X values, and you're going to see those words a lot in the lesson where they say find the domain or find the range. So you need to know that when they're talking domain, they're talking X. When they're talking range, they're talking Y's, okay? And then there is, for the last thing, what's called a relation. And the relation is just, if you kind of think like relationship, right? Relation. It's a pairing of a domain and a range. So your relation is your X, comma, Y. So it's like naming the point, right? It's the X and the Y together. They are in relationship with each other, okay? So what we're going to do, there's two different things we're going to do. We're going to do what's called a mapping diagram today, which sounds weird. It's not, you're not making a map. Okay, it's not that kind of mapping. And then we're going to do what's called the vertical line test. So those two things, and then we're done. All deal with domain and range. All right, so first example. Thanks, Matt. Did you show me your homework? You didn't, right? Homework? You can just send me a picture of it otherwise if you want to do it when you get to study hall. I don't care. Totally up to you. Okay, for example 1. This is mapping diagrams, okay? Here's what it will say. It's going to say identify the domain and range of each relation. Okay, so identify the domain, identify the range, then do a mapping diagram. And then you're going to determine, is it a function? Okay, so a mapping diagram is going to help us determine if something is a function or not, okay? So we're going to start with a bunch of points. Thank you. It's for you. So you're going to start with this setup. You will have these brackets, and then within the brackets, they're going to give you points. So -2, 0.5 is one of your points. Okay, another one is 0, 2.5. Another one is 4, 6.5. And the last one is 5, 2.5. Okay, and then they put brackets around it again. So what they're saying is this whole set of numbers is taking a bunch of relations and seeing how do they fit together, okay? Now, here's the deal. You need to come up with a domain and a range for this, okay? And we said the domain is your X values, The range is your y values. So if you look at this setup, your domain right now is going to use, and I'm just going to color code, okay? So domain being red. Oh, that's not red anymore. Sorry. Domain would be x, 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 and x. Do you see how those are all the x values, right? It's the first number in your parentheses. Okay, here's the rule. When you set up your domain, you have to go in order, in numerical order, and there are no repeats. So if there were 2 4s, you would not write 2 4s. You would write 1 4, okay? So if I take these numbers and I do that, here's how you're going to write it. You do your brackets, okay, and then you just list them in order with no repeats. So what's the smallest x value? -2. What's the next smallest? 0. Then 4. Then 5, okay? And you finish off your brackets. That's how you would list your domain, okay? That's your x values. Then you do the range, okay? So the range is your y values. So 1, 2, 3, and 4. Those are your range values, okay? But same rule applies. They have to go in order, and you don't want any repeat numbers. So what's your smallest number? 0.5. Okay, what's your next number? 2.5. What's your next number? Then 6.5. So notice there's 2 of those 2.5s. You only write it once, okay? Then you write your 6.5, and that is your range. So when they ask you for your domain and range, this is what they're asking you for. Make brackets and put them in order with no repeats, okay? Then they want a mapping diagram. And the mapping diagram is really easy if you've laid out your domain and range, okay? Here's what you do for a mapping diagram. You will have your domain on one side and your range on the other side. And you're going to put your domain and range in order across from each other. So my domain, if you just look up top, goes -2, 0, 4, and 5. Okay? Put them in the order you see, exactly how you wrote it up here. Then your range is 0.5, 2.5, and 6.5. Okay? The way a mapping diagram works is once you have your domain and range laid out like this, you go back to what you started with. Okay? So we're going to go back up here. And now you're going to draw lines to each of your relations. So my first one was -2.5. So I'm going to draw an arrow from -2 to 0.5. Okay? Your second one is 0, 2.5. So I'm going to draw a line from 0 to 2.5. Your third one is 4, right? This point up here, 4, 6.5. So I draw an arrow there. And then my last one is 5, 2.5. Okay, this is a mapping diagram. The question they want you to answer, if you look back up here, is this a function? And here's the rule. In order for something to be a function, every x value can only have one y value, okay? The way you can see that on a mapping diagram is if you only have one arrow coming off of each x value, it is a function, okay? So we would say, is this a function? Yes, it is a function. Because there is only one arrow coming off of each number. Now notice this. There's 2 arrows landing on your range. That is okay. Okay? What is not okay is when there's 2 arrows coming off of your domain, off of one domain number. Okay? So in other words, if I gave you this setup, if this was -3, 2, and 4, and this was 0, 1, and 3, and this was my domain, and this was my range, and I did this, and this, and that, and that. This right here makes it not a function because you have two arrows coming off of your domain. Does that make sense?
But why would you have two arrows?
Because this is saying if I plug a -3 in, I can get out of it a 0 or a 3. Well, a function, when you plug a value in for x, you only get one y out of it. So that means this is not a function. Okay? Multiple x's can get you to the same y, but every x, yeah, you can only have one y value per x value that you have. Okay? So this is yes, it's a function. This is no, it's not a function because of that double arrow coming off. Does that make sense? Okay, let's do one more mapping diagram, and then we'll move on to the vertical line test, which is really easy. All right, let's say our points are 6, 5, 4, 3, 6, 4, and 5, 8. My bracket got a little extra hump in there. All right, so domain and range-wise, can you tell me the domain? So we want it in order with no repeats, right? So we're looking at all of our x values in order, no repeats. So can you tell me my domain right now? What's the smallest? 4, 5, 6. Okay, and you only put 1 6. Even though there's 2 6s there, you write 1 down. Okay, no repeats. Then our range, so start your brackets. You have 5, 3, 4, and 8. So how do I write my range?
3, 5,
3, 4, 5, 8. Okay, so that's my domain and range. Now I make a mapping diagram from that. So I'm going to do domain here, range here. I don't expect you guys to color code. I'm just trying to help you see what goes where. So my domain is 4, 5, 6. So under my domain, I'm going to write 4, 5, 6. My range is 3, 4, 5, 8. So that's going to be 3, 4, 5, and 8. Okay? Dustin, what are you doing over there? Are you taking notes on that thing? Okay, put it away and take notes, or put it away altogether. So with this setup, now your job is to make the mapping diagram happen. So you're going to draw the arrows in where they apply. So your first point is 6, 5. So you're going to start at 6 and connect to 5. Okay? Your second point is 4, 3. So you're going to start at 4, draw an arrow to 3. Your third point is 6, 4. So you're going to start at 6, draw an arrow to 4. And then last one is 5, 8. So from 5 to 8. The question is it a function?
No.
Why? It's not a function because you have 2 arrows from the 6, right? So this makes it not a function. Keep in mind, it is okay to have 2 arrows meeting at the range. That's okay. You just cannot have 2 coming off of the domain. Okay? Yeah.
So you're saying this has to be from 2 different numbers, but
It can go to the same one, but it has to be, your left side can only ever have 1 arrow coming off of each number. Okay?
X can only have 1 y, but y can have
Multiple x's.
Oh,
Okay? Okay, so that's mapping diagram. Are there any other questions on mapping diagrams? Okay, then the vertical line test, this one is pretty short and sweet. Basically, the vertical line test says if you can take your pencil and drag it vertically across a graph, if you hit 2 points vertically at the same time, it is not a function. If you don't, it is a function. Okay, that's the vertical line test. So use your pencil as a vertical line on a graph, and you'll see what I'm talking about. so here's the deal. If I give you, let's say I give you this set of numbers. -4, positive 2, sorry. -4, 2. -3, 1. 0, -2. -4, -1. And 1, 2. Okay. If you still have graph paper, by the way, pull that out. If you don't, you're welcome to go grab a piece up here. But you're going to graph these points to do the vertical line test. So go ahead and get that graph paper out. I will pull mine up while you are getting yours out. All right, so here it is. Your first job is to make sure you're plotting points correctly. So if you struggle with how to plot points, which some of you were doing on the quiz, make sure you're paying attention right now, okay? -4, +2 means you're going 4 to the left, 2 up. So from 0, 0, 4 to the left, right? 1, 2, 3, 4, and then 2 up will put us right there. Okay, so there's one of my points. Then you plot -3, 1. 1, 2, 3, 1. Okay, that puts us there. 0, -2 puts us here. -4, -1 puts us here. And then 1, 2. Okay? What you're going to do is you're going to do a vertical line test on this. So you may use your pen, you may use just your eyeballs to look at it. I don't care how you check it, but essentially what you're doing is taking a vertical line and seeing, do any of these points fall perfectly vertical of each other? So if I were to draw a line here, there's no points there. A line here, no points there. But right here, how many points did I go through? 2. If you go through more than 1, it is not a function. Okay, so we would say for this is not a function because Fn, by the way, represents function. Okay, so not a function because of these 2 points right here. If they are vertical of each other, they cannot be a function because your x, right, this point here had an x value of -4, and this point here had an x value of -4. You cannot have 2 of the same x value. Are you sure?
Yeah, I'm thinking.
Okay. Yeah, Avery.
Do we have to graph it, or could we just, or like, is that a way to see it easier? Like, could.
I mean, you can technically tell it just by looking at this, but if it says do the vertical line test, it means you got to plot it.
Okay. And then also, if with the first coordinate, if there was 2, there is 2 positive 2. So like, would that, like, if the 4s were different?
If the 4s were different, but there were both of the, that would be fine. That's still a function.
Okay.
Wait,
Yeah.
if they're
Vertical,
not
this way.
vertical.
Horizontal doesn't matter.
Okay.
Horizontal can still be a function. It's vertical that can't be a function. If there's 2 on a vertical line, it is not a function. Yeah. What did I just do? When I plotted all the points, I just checked, are any of these directly over top of each other vertically? So if I drew in a bunch of vertical lines, if you ever hit 2 points at the same time with a vertical line, it is not a function. Okay? All right, let's do one more. This one, they're not going to give you the numbers. You're going to come up with them. So let's say I give you y equals a negative x squared plus 3, and I want to know if it's a function. What you're going to do is you're going to do a t-chart so that you can graph it, Okay, and we'll just do our typical -2, -1, 0, 1, and 2. By the way, some of you graphed on the quiz and it looked like this. Have we ever done a graph that looks like that? Nope, they're all U's or V's or straight lines. So make sure when you see something like that, your little warning in your head goes off. Hey, that doesn't look familiar. Something's wrong here. Because whenever there's an x squared, it's what shape? It's U-shaped, right? So like this or like this. This one's going to be upside down because it's negative. Not in this class. In Algebra 2, you will. Yeah, but not in here. Okay, so if I'm going to plug -2 in right here, I'm saying a -2 squared, that's +4, but it's a negative, so -4 plus 3 is -1. Okay, then I plug a -1 in. -1 squared is a +1, but they're saying make it negative, so that's -1 plus 3 is 2. Then we plug a 0 in. A -0 squared is 0, plus 3 is 3. Then plug a 1 in. 1 squared made negative would be a -1, plus 3 is 2. What do you think the 2 is going to be? Do you see the pattern? -1, 2, 3, 2, back to -1 is what it does. Okay, so what you're going to do is you're going to graph that. So take your graph paper, and we're going to plot. So -2, -1 would be right here. -1, 2 is right here. 0, 3 is here. 1, 2 is here. And then 2, -1 is right there. Okay? When you graph that, you get that U-shaped curve. If you take a vertical line to those, are you hitting anything, any 2 at the same time? No. So is this a function?
Yes.
Yes, because it passes the vertical line test. Okay, questions on that?
No.
That's your lesson.
Oh,
You have 10 minutes still, which you can get a lot of stuff done in 10 minutes. Yes, Eliza.
yep, sure.